Hello everyone and welcome back to my guide videos. Today we're going to be learning about radicals, simplifying operations on radicals, rationalizing radicals, and solving equations and word problems. So I already started on this first one just to give you all a heads up. So let me explain this. So this is converting from what they call this square root form, I forgot, but square root to exponent form. So first you want to take this number inside and put it here on the numerator and the number here on the denominator. By the way, just for this, if there's nothing here, like no number here in the fourth spot, it's just 2. And if there's no number here in this spot, it's just 1. So we just made it x raised to 2 over 4, and we simplified it to 1 over 2. Let's try that again, because number 2 is actually the similar case. So it's going to be 6, okay, no, 3 cube root of m to the 6th. So let's do this again. First, we want to take out the square root, so just draw m. Then take the number here and put it in the numerator. Then put this number, which is 3, in the denominator. M equals 6 over 3, or by simplifying, it's m squared. Next one. Number 3. It's just the square root of y over 8. So once again, if there's no index, that's what they call it here. It's just 2. So y equals this number over here, which is 8 over this number over here, which although not shown over here, if there's nothing there, the index is 2. So y equals 8 over 2, or y raised to 4. So this is the simplest type. Let's now move on to the ones that you have to take out something here. And this will require us to know these numbers here. For now, let's just focus on the square numbers, not the cube numbers. Okay, let's start with number 4. So number 4 is the square root of 40. Now, we want to take a look at these numbers below 40. Do you see any number, other than 1, of course, other than 1, do you see any number that will divide 40 into an integer? The answer is yes, and that number is obviously 4. And based on this law of radicals, we can also say that square root of 40 is equal to square root of 4 times square root of 10. But we can also derive 4 into 2, which makes it 2 square root of 10. And that's the answer right there. Next one, number 5. So same case again here, square root of 50 this time. Do we see any number that we can divide 50 into, which will result in an integer other than 1? The answer is once again yes. It's 25. By the way, for numbers that have more than, like let's say we have a number that's divisible by 16, 9, it's always better to pick, the correct answer is to best pick the bigger number. Anyway, we don't encounter that, so we don't need that. So it's just 25, which means it's equal to square root of 25 times square root of 2. And there we have it. Just make it 5 square root of 2, because square root of 25 is 5. Lastly, let's try to simplify square root of 300. The square root of 300 is equal to, do we see any number that can divide these by, well, exactly, 300, exactly. It's obviously going to be 100 over here, which means we do square root of 100, square root of 3, simplify, then square root of 3. Alright, looking smooth. Next one, number 7. Square root of 162. We know the drill by now. Just look for a number that is, once again, going to be a factor of 162. And it might be hard to tell at first, but if you recognize it, as you can see, 16 is over here, and it's divisible by 8. And 2 is divisible by 1, which is 81. So usually you're not going to deal with bigger numbers. So it's just square root of 81 times square root of 2. Remember, if you're unsure, just try to do trial and error. Which means the correct answer is 9 square root of 2. Because once again, this is just 9. Square root of 81 is just 9. Alright, now on to cube root. Okay. I think I might just need to add 125 there. Yep, okay. So number 8. Cube root of 80. Simplify that. Same thing with square roots over here. Cube root. So do we see any number here that you think could divide 80 into a whole number? And the answer is obviously yes. It's 8. So we want to do cube root of 8 times cube root of 10, which is just 2 cube root of 10. Lastly, this is the trickiest one by far. Number 9 is the trickiest one by far, but it's not too scabby. Although I do need to expand our square root numbers all the way to 144 this time. Do a little expansion over there, but yeah, I think the numbers are until, I believe, until 15, so I'll just list them when needed, but for now we don't need it. So let me just fix this up real quick. There. So square root of 288x to the 9th power. Well, how do we do this? First and foremost, we can obviously take out 144, because this is just a factor of 144, if you haven't told already. It's good to see. So it's just going to be 144 and what do you call this? 2x9. However, we can also take x out. So we have, wait, let me simplify first. 12, 2x to the 9th power. However, we can actually take x raised to 9 out. How do we do this? So just do 9 divided by 2 is equal to 4, remainder 1. Now, what you want to do after dividing is that you want to take 12x raised to 4 out, because 4, and then the remainder 1 stands for the 2x inside. So that once you put this back in, it becomes x raised to 8. And then this will add x raised to 1. So x raised to 9. That's why it makes sense. And this is the final answer, if I'm not mistaken. So yeah, let me just double check everything to make sure everything's correct. But this is how you simplify radical expressions. I'm pretty sure I've covered all the cases. Alright, let me just encircle this to indicate that it's completed. Then we'll move on to the next topic. I made sure that everything is correct. So yeah, all answers are correct. So take a screenshot if you need to. Actually everything, because yeah, everything here. And then we will move on to the next problems that we have. Let me just set it up real quick and I'll be back here. Okay, so like I said, the next one would be operations on radicals. So let's try to do that real quick. So there are 4 cases that we were taught. So let's discuss each one of them. So we got this first one over here. Let's try to roll number 1 first. 3. It's gonna be 3 square root of 6 minus 4 square root of 6. Now, we want to check if both numbers in the square root are the same. They are, and both have the same index. In this case, it's 2. It's just not shown here. But once again, if there's no index, it's 2. If those requirements are met, we can immediately just subtract the 2 numerical coefficients here. So it's just going to be 3 minus 4, which is equal to negative 6. Negative square root of 6. Negative 1 square root of 6. Then it becomes negative square root of 6. I'll just put ABC here. Next, 1b. It says negative 3 square root of 7 plus 4 square root of 7. Once again, check if the both numbers here are the same. Then check if the index are also the same. Once it's the same, we just add the numerical coefficients. Negative 3 plus 4 is just 1 square root of 7. Or just simply square root of 7. Next is 1c. That's going to be negative 11 square root of 21 minus 11 square root of 21. So once again, same drill here. We're going to check if the numbers are the same. Check if the indexes are the same. Once we're done, we just copy the square root 21. Then we simplify using the numerical coefficient. Negative 11 minus negative 11 is negative 22. Next one, let's go for case number 2. So case number 2 is just adding and subtracting once again, but this time we need to take out some of the coefficients because as you can see they're not simplified yet. So the first one is negative 2 square root of 3 plus 3 square root of 27. Now as you could see, once again, if we try to check, are the numbers the same? No, but the indexes are the same. So applying from our previous topic of simplifying radical expressions, we need to make this the same, which means we need to make the square root of 27 into a square root of 3. So let's check if there's a number that will perfectly divide 27 in this list. And as you could see, there seems to be one. It's 9. We're gonna do that. So it's gonna be 3 square root of 9 times square root of 3, or just 3 times square root of 3, or 9 square root of 3. And then we copy that one down all the way here. 2 square root of 3 plus 9 square root of 3. Are these the same number now? Yes, and they still have the same index. So we're just going to change it, simplify it by using the numerical coefficients. So negative 2 plus 9 is 7. And then copy the square root of 3. Alright, next one. 2b. We have 2 square root of 6 minus 2 square root of 24, right? Okay. So once again, same drill with this one. We need to find a square number that will perfectly divide this so that we end up with 6 in the square root. So looking at our list over here, it seems very obvious that the number is 4. So negative 2 is equal to 4 times square root of 4 square root of 6, or negative 2 times 2 square root of 6, negative 4 square root of 6. Copy this one down. 2 square root of 6 minus 4 square root of 6 is equal to negative 2 square root of 6. So as you can see right here, 2 minus 4 is negative 2, and just copy the square root. Last one for row 2 is 2c. Negative 3 square root of 18 plus 3 square root of 8 minus square root of 24. Okay, let's try to simplify this pretty interesting actually cases here. So let's try first to simplify this one. So we can, that's 18, which is divisible by 9 only. So it's just gonna be negative 3 times 3, times 9 times square root of 2. Then just negative 3 square root of 2, or just negative 9 square root of 2. Now, let's try to factor this one out. This one also seems to be divisible by 2, so let's try that. So 8 is divisible by, indeed, 4. So that's just going to be plus 3 square root of 4. 3 square root of 4 square root of 2 plus 3, 2, parentheses first, 3, 2, 2, then plus 6 square root of 2. Then we're gonna simplify square root of 24, which is actually, it's also divisible by 4. So once again, square root of 4 square root of 6 plus, that's just 2 square root of 6. Now we're just going to try to simplify that, and so negative 9 plus 6 is negative 3 square root of 2. It's this one, plus 2 square root of 6. I don't think it can be simplified any further. So let me just check my answers to make sure everything's correct. Okay guys, sorry, but I made a little bit of a mistake. This is negative 4, which means this is negative 2. This is negative 2, but other than that, everything else is correct. This is the correct answer. So we can move to cases 3 and 4. So let's do number 3 now. Square root of 12. 3 square root of 12. 3 square root of 12. Then multiply by square root of 6. Now just multiply these two to get 3 square root of 72. However, 72 is actually divisible by one of these numbers. Take a moment to take a look at the numbers and check which is divisible. You might be able to say it's 36, which is correct. So it's just 3 square root of 36 square root of 2, or just 3, 6 square root of 2, then 18 square root of 2. That's the correct answer. How about for 3b? Hold on. Okay. So next is going to be 3b. It's gonna be negative 4, 15 times negative square root of 3. Okay, so first I'm going to add this one here, negative 1, just an imaginary placeholder. So negative 4 times negative 1 is equal to 4. Then 15 times 3 is equal to square root of 45. Let me just make that closer there. Square root of 45. Then 45 is divisible by 9. So it's going to be 4 square root of 9 times square root of 5. 4 times 3 square root of 5. 12 square root of 5. Okay. Next is 3c, which is simply just square root of 20x squared times square root of 20x. So let's multiply these two. So it's going to be equal to square root of 400 x cubed. However, 400 is actually a perfect square number. I'm not going to list it, but it's obviously going to be 20 and 20. So we can actually take the 20 out along with the x, because this is more than 2. So this is x and then square root of x. Yeah, correct. Because this one, if we put this x back in the square root, it becomes x squared. X squared times x is x cubed. So this is the correct answer. Right? Take a moment to just take a little break here. It's a lot. And check if you've noticed or like you've noticed any mistakes, and I'll be back to answer finally the last one, which is D. This is definitely the hardest, or 4, part 4. Okay, last example for operations and radicals. Let's do number 4. So first it's gonna be square root of 3, and then in parentheses 5 plus square root of 3. So you just have to multiply each term to this one in the parentheses. So let's see what we get. So 5 times square root of 3 is just 5 square root of 3 plus 3, plus simply 3. And let me just check if there's something we can do. Not really. So this is already the final answer, because we just multiply these two. 5 square root of 3, then 3 times square root of 3 times square root of 3 is 3. Time for 4b, which is, okay, this is going to be the FOIL method. Okay, so it's going to be a little bit complicated. So negative 2 square root of 3, yeah, plus 2, yeah, plus 2. Then we got a square root of 3 minus 5. So it's just going to be the same FOIL method. So let me just box up the terms so that you don't get confused. Okay, so let's get started. First, negative 2 square root of 3 times square root of 3 is just negative 2. Sorry. Negative 2 square root of 3 times square root of 3 is just, that's going to be 3 times negative 2, or just negative 6. So we just erase all of this. So the first term is going to be negative 6. Then negative 2 square root of 3 times negative 5. So we have to do negative 2 square root of 3 multiplied by negative 5. So that's going to be 10. Ooh. Sorry guys, I got a little bit stumped there, because if we actually multiply this, it ends up being a negative number. So we actually just keep it intact. So we add this term to our list. So it's going to be plus 10 square root of 3. Now that's this one done. This one done. Next is 2 times square root of 3. So that's just 2 square root of 3. Then lastly, it's going to be 2 times negative 5, which is just negative 10. Let's simplify like terms. So negative 6 times plus minus negative 10 is just negative 16 plus, yeah, 12 square root of 3, which should give us our final answer. Sorry that I got a bit stumped on this one, because yeah, I don't want any imaginary roots, but that's the correct answer. Okay, so the last problem is actually pretty confusing. So we need to, this is how I do it. I don't know if there's a more efficient solution. There probably is. So we have this problem over here, which for me, I like to make everything a square root first. So to make this 7 into a square root, we have to put it as square root of 49. And then n cubed in a square root would be n raised to 6, so that the statement still remains true. Then plus square root of 12. Then we can actually just apply the law of radicals here again. So 49 times 6 is 294. 294, right? Let me just make sure. Yeah, 294. Sorry about that. Anyway, it's 294, square root of 294, and then n raised to 7 plus 72 n, square root of 72n. Let me just go here now. Anyway, so once again, we can just take out the 7 for good measure. Yeah, 7. We can take again the 7 for good measure. And then you're left with 6, n raised to 7, sorry. And then plus 72 n square root. Now both sides can be simplified. First, we're going to divide 7 by 2. That is 3 remainder 1. So 7 n raised to 3. And then keep the n inside. And then this one can be expressed as 36 and 2n. Or just 6 2n. Kind of looks like a Z. Hold on. There we go. And I believe that is the correct answer. Yep. So this is the correct answer. This is definitely the most complex out of all of them. So yeah, it's just good that we managed to solve it. Alright, time for the next one. I'll take a little break and then I'll be back to rationalizing radicals. Wait. I just realized something. Hold on. 6n. Yeah, I completely neglected that one, but it's 6n, okay? 6n, 6n, and 6n. There we go. That's the final answer. Sorry, guys. But yeah, I'm gonna move on to rationalizing radicals. Okay, so now we're going to go to rationalizing the radicals. So these are two cases. One where the denominator is going to be a monomial like this, or a binomial like this. Okay, we have to rationalize the denominator for all three of these. So let's start. Okay, for 1a, we want to put square root of 15 over 5 square root of 20. Remember, when rationalizing, our goal is to simply remove any square roots. So in this case, when you're in a monomial, all you really need to do is just copy and paste that. So 5 over 20 and 5 square root of 20, 5 square root of 20 over there. Then you just multiply. So that will become 5 times 5, 25, and then 25 times square root of 20 is 20. So that becomes over 25 times 20, because 5 times 5 and square root of 20 times 20. Which is equal to, I believe, let me see, 25 times 20, 1,000, right? 25 times 20, oh no, my bad, 500, it's 500. So it's 500 over 5, so it's 5 square root of 300. Or we can simplify this further by doing 5 square root of 100 square root of 3, or just 5 times 10 square root of 3, which is just 50 square root of 3, but we can simplify it further, 50. That's equal to square root over 3 over 10, because we just divide both we just cancel these each other out. So 50 over 500 becomes 1 over 10. And that's the first one. For the second one, let's do the second one now. It's going to be 3 square root of 20 over 2 square root of 4. Same drill here. We're just going to duplicate these two. 2 square root of 4 and 2 square root of 4 at the top as well. That's equal to, so 2 times 2 is 4, and then 4 times square root of 4 times square root of 4 is also 4. So that's 4 times 4, which is 16. So just 2, so that's just 4, and this is also 4, which makes 16. And we just multiply these two. 3 times 2 is 6. Square root of 20 times square root of 4 is square root of 80. But we can simplify that further by, as you can see, it's divisible by 16. So we can just do, square root of 16, square root of 5, or simply put 6 times 4 times square root of 5, or just, what's this? 24 square root of 5. Is that correct? Yep, correct. But we can simplify that as well because they're both divisible by 8. So it's just going to be 3 over 2. Because we can divide this one by 8 and divide this one by 8 as well. Of course, copy the square root of 5. That's the answer. Alright, I'm just going to take a look. Let me just make it 1B. Okay, I'll take a look at C because it's a little complex. Okay, it's now time to solve the 1C, which is this one. I have the problem here. So same case again for 1B and 1A. Just copy the Copy the same thing over here and as well as the top. Then we just multiply from there. This is equal to, so from here it's 16 because 4 times 4 is 16. 16 times 5xy cubed. So let's just write there. 16 times 5xy cubed. Now the reason we put that here is because square root of 5xy cubed times square root of 5x cubed is just 5xy cubed. And 4 times 4 is 16. Simplifying this, we will get 80. Now same thing from here from the top. It's gonna turn to 4. And then square root of 15. Because 3 times 5 is 15. X squared times x is x cubed. While y cubed times y cubed is y to the 6th power. And we can simplify a lot of things here actually. First, let's take out the x from the square root as well as the y cubed because, well, and keeping 15x there. The reason why we do this is because we divide the 3 by 2, which is 1 and a remainder 1. So that 1 goes here, while the other one goes here. Same thing here. 6 divided by 2 is 3. Hence, we take the y raised to 6 out of the square root and make it out as y over 3. Because 6 divided by 2 is 3. Just copy 80xy cubed. But we can simplify it further because 4 and 80 are both divisible by 4. So it becomes xy cubed over over 20 xy cubed square root of 15x. But we can also cancel these two out. So it just becomes, after all of that, it becomes 15x square root of 15x over 20. And that's the final answer. It's a pretty lengthy process, so it's understandable if you don't get it in the first attempt. Okay, now time for case 2, where this is where we have to find the conjugate. So the conjugate is just basically, okay, for this one, the conjugate is just 4 minus 4 square root of 5. So just change this one into the opposite operation. So how does that work? So let's start with 2a first. We're gonna have 3 over 4 plus 4 square root of 5. So we're gonna do the same multiplication, but instead of just copying it, we find the conjugate, which in this case, since it's 4 plus 4 square root of 5, it's gonna be 4 minus 4 square root of 5. And then same thing here, 4 minus 4 square root of 5. Then we just do FOIL method here. So first, we do 4 times 4, which is the easiest, 16. Now, first, the outer and inner terms will cancel each other out. Because this is 4 square root of 5 times 4 square root of 5 times 4, and 4 times 4, negative 4 square root of 5. So these two will just cancel each other out. These two highlighted in red. So you don't have to do them because they're just the same thing. Each of them just cancels each other out. Then we do this one. 4 square root of 5 times 4, negative 4 square root of 5 is just negative 16 times 5, which is negative 80, which in turn is just negative 64. There. Now for the top, it gets a little bit tricky, but we remember that it's just this. So 3 times 4 is 12 minus 12 square root of 5. Okay, so is this the final answer? Yeah, I think this is the final answer. Let me just check to make sure it's correct. Okay, this is already the correct answer, but we just have to simplify a little bit further. These are all divisible by 4. So it's going to be 3 minus 3 square root of 5 over negative 16. And that is the final answer. So let's move on now to 2b. Okay, let's move on to our next problem, which is 2b, this one. I've already written the first steps out. However, I just want to note that for 2a, which is this one, you can actually write it in these two terms. This one is the more acceptable one. So you really just have to be more keen on how to spot how can we simplify it further. It usually results in a half-point deduction on the test, so we have to be careful for that. Anyway, the conjugate is, by this point you should know, but as you can see, I just swapped the negative here for a positive sign. Now, let's rewrite this one. So this is going to be 25 because negative 5 times negative 5 is just 25. Then this becomes negative 3 square root of 3 times positive 3 square root of 3. So negative 3 times positive 3 is 9. And square root of 3 times square root of 3 is 3. So negative 9 times 3 is negative 27, which is just negative 2. Then we go to the top. This becomes negative 25 plus 15 square root of 3. Then we could factor this one out. It can become 5. Yeah, 5 in parentheses negative 5 plus 3 square root of 3 over negative 2. Yeah, that's the correct answer. Or we could, this is answer, but we can actually redistribute the negative sign. So we just flip everything's sign. So 25 becomes minus 15 square root of 3. Then this becomes 2. Just redistribute the signs. Then we factor. 5 over 5 minus 3 square root of 3 over 2. And there we go. That was a pretty tricky one even for me, but that is the correct answer. I'm really sorry. This topic is really just very confusing. Last but not the least is 2c. In 2c, we got square root of 2 minus 5 square root of 3. All over 4. 4. And you get square root of 2 minus 5 square root of 3 is equal to, and then we multiply by using the conjugate. Square root of 2, this time plus 5 square root of 3. That is equal to, let me just put it here. So that's equal to 2 minus 75, because 2 Then this is negative 25. Then this is 3. So 2 negative 2 minus 75, which is negative 73. Then we do this. It's just 4 square root of 2 plus 20 square root of 3. Yeah, 20 square root of 3. And can we factor it? Can we factor the top? Yeah, we can factor the top. That means it's just square root of 2. Oh no, we can't. No, we can. Square root of 2 plus 5 square root of 3 over negative 73. And negative 73 is a prime, so that's the final answer. Let's just box that. And yeah, I think we're done for this topic. Let's move on to the next topic. Yeah, this is the correct answer. I just forgot to put the 4. But that's how we factor it out anyway. So it becomes 4 square root of 2 plus 5 square root of 3. So that's the final answer, this one. Now let's take a screenshot and move on to the next problem or topic. Okay, for our last topic, we're gonna solve radical word problems. I have 3 different types of problems that we may encounter during the test. So here's how to solve each and one of them. First is the square root of 2 consecutive odd integers is equal to 8. Find the larger integer. We're gonna use the RESA method. First, let's start with the representation, or R. So we know that the square root, so we put the square root symbol, of the sum of 2 consecutive odd integers. 2 odd integers would just be x plus 2. For example, 1 and 3, where x equals 1, and 1 plus 2 is indeed 3, hence they are 2 consecutive odd integers. So that's our representation for this one. And we know that it's equal to 8. So we don't need to do that. So we do that in the equation. 2x plus 2, so we just add all of these up, is equal to 8. Now for the solution. We can square both sides over here. So square root of 2x plus 2 squared equals 8 squared, which means 2x plus 2 equals 64. And then we just transpose it. Oh wait, let's make it easier to understand. So we just break it down. X plus 2 equals 64, which means by doing this, it's actually 31. X equals 31 because 2x plus 2 equals 64. X equals 31. And then the bigger integer would be x plus 2 equals 33. So we're looking for the larger integer, so the answer is 33. Next, the side of a square measures square root of 5 plus 3 units. Solve for its area. So we know that a square has equal sides, which means all sides will be equal to square root of 5 plus 3. So let's just do this real quick. So to find the area, we just multiplied a side by another side, which are just the same. So this is our representation. Next is the equation. So we just do square root of 5 plus 3 square root of 5 plus 3 equals area. Then solution. So this is equal to 5. 3 square root of 5. 3 square root of 5. And this would be 9. So 14 plus 6 square root of 5. There we go. Finally, to save a woman from a burning building, the fireman placed a 10-meter ladder against the window. The foot of the ladder is 2 meters from the wall. Let's try to just draw this first. So let's pretend that this is going to be the wall. So this is going to be the wall, and this this green one will be the ladder. And let's draw an imaginary blue line to indicate the distance from the wall. So we have a 10-meter ladder against the window, which means this is the ladder. Meanwhile, the ladder was 2 meters from the wall. Now, if you may have been observant, we can just use Pythagorean theorem here, which states that in this case, we're missing. So this is going to be your A, this is going to be your C, so we're missing B. We know that B equals C squared minus B squared minus B squared is equal to C squared minus A squared. Or let's just square root it. B equals square root of C squared minus A squared. So substituting the values, A is equal to 2 squared. So let me just draw R. I'd say E. E is this one. 10 squared. Then S. S would be this one. Then we just have to simplify. It's just going to be 4 square root of 6. Because this is divisible by 16. So square root of 16, 6 is 96. So yeah, they're the same. And that's it. That's the answer. And there you go. That is your radical review for the upcoming test for radicals. And I hope you all enjoyed, and make sure to take a screenshot. And thank you once again for watching all the way to the end. For this one, I aim to have as much problems to ensure consistency. So in my previous guides, I only did 1 or 2 examples. This time I really went with a lot of examples. Hope this video helps. Share it to a friend if you need it. Please take care of yourselves. And once again, thank you so much for watching Study Guides. I'll see you in the next one. Bye.